I want to extend a warm welcome to you from Ontario, Canada, which is where I'm joining you from today. And we've changed things up just a little, trying to keep the Hackfests fresh. This one, we're definitely trying to get into some of the details under the hood of OSM, and there's going to be a little bit more time spent towards the end of the week on development. So with that, we have created a simplified workflow that we're going to be using this week. So, a little bit of background. What is OSM? It is a Network Service Orchestrator. So OSM, for those that don't know, stands for Open Source MANO, which of course MANO is yet another abbreviation, which stands for Management and Orchestration. Management and Orchestration. And what that's all about is starting software, installing software, configuring the software, arranging services in the network, changing switches or flows between endpoints in a network, and bringing everything together to be able to bring up services quickly and efficiently. And it is all based upon standards that have gone through the ETSI solutions process. So what are some of the benefits of OSM? Well, we provide a well-known information model that's completely aligned with ETSI NFV SOL 6, which means that this is interoperable with an industry standard. Any SOL 6 descriptor can be brought to OSM and be usable by OSM. So it allows you to model the network service without worrying about the details of, okay, well, is this OpenStack? Is this Azure? Is this Fog5? Is this VMware underneath the hood? OSM provides plugins and abstraction layers for all of that, and it's just modeled based on the standard. So it models and automates the full life cycle of network functions, which includes virtual, virtual can be containers or VMs. So don't just think of virtual as VMs. There's also Kubernetes orchestration that falls under the virtual side of things. Network functions can be physical, which means that this is a purpose-built appliance and it already exists. The software is already up and running, and you're just going to be managing its configuration, not its life cycle. Or hybrid, which is a combination of virtual and physical. These functions get pulled together into what we call network services, which is sort of the atomic unit of deployment. So a network service can contain one function, or it could contain 2 or 10 or more functions. And that network service is managed as its life cycle is managed as one unit. And then network services can be put together into what are called network slices. And that is an end-to-end functional unit of one or more network services where the slice can be deployed repeatedly. And it's possible that you have some network services that are going to be shared and won't be redeployed, and other network services that are going to be dedicated to the slice. So that same slice can be deployed twice. Some services will be only managed and deployed once, and other ones will be created on demand. The overall orchestration includes the initial deployment, which we call day 0, or day 0 and day 1, which is basically instantiation, initial configuration, installation of the software, making sure that it's ready and localized to the network. and then daily operation and monitoring of the software, which is day 2. And that is ongoing care and feeding of the software. Some people like throwing, sort of a day N type of terminology at this, or day end, as in last day. OSM also does cover destruction of network services. So tearing it down, cleaning up the resources, freeing everything up so that it's available again. So it is the full life cycle that OSM does provide. So an overall workflow must be a complete end-to-end thing, where everything about the software that is being managed is automated. So the typical workflow is where we simply take the software from a vendor or software from somewhere. Maybe it's just open source software and we're bringing it on, and breaking that down to a series of descriptors and figuring out how that is actually deployed, or what it's going to look like, modeling it in Sol 6, and then it'll instantiate that service and make it manageable, which is what we call day 0. Initialize it or localize it to the network so that we can talk to it and we can reach it, and it's capable of providing its base functionality, day 1. And then continue to operate the service, monitoring, reconfiguration, scaling. And by scaling, we are referring to horizontal scaling, which is adding additional instances, not vertical scaling, which means adding additional CPU or memory to an existing instance. So in typical cloud native or cloud service architecture, scaling is accomplished by adding more units, not by increasing the current capacity of an existing unit. One quick note here on going back to the onboarding workflow. There is an VNF onboarding task force in OSM, which is dedicated to helping people bring software online. There is a lab for this, so there are open resources available, open through services through the from Etsy. Sorry, I was just looking at the chat trying to make sure that that question was answered. Thank you, Andika. Yeah, so the VNF Onboarding Task Force has a lab sponsored through Etsy, and we're able to, anyone who's interested in, hey, I've got this piece of software, I want to be able to bring it on board, write a Sol 6 descriptor for it. This is where vendors can come, or people can come and participate in this, and we also are there to help you break this down. Okay, orchestration. So this is a critical piece when it comes to being able to manage the software. So there is this last mile workload specific workflow that needs to happen. It's one thing for me to just deploy a database. I can install the software, okay, the database is up, but maybe there's some initial users and credentials that I want created, and I don't want to hard code those ones. I want these to be generated and a random password generated, and that password shouldn't be something that I have to supply, and I shouldn't have to go around and give that password to every other application that needs it. So OSM has included the Juju Charm software inside of it to manage a bunch of this. Juju Charms, the Juju software is open source. It is available online. It's got its own, Git repositories and life cycle and work that goes along with it. So not everything in OSM would necessarily be found in OSM. We do leverage external libraries where it makes sense. Mohammed, yes. How can we use Juju to automate Ansible playbooks? Well, guess what? We're doing that this week. And Thursday, I will be able to spend some time diving deep into that. But today, this afternoon, depending on your time, but under the physical network functions, we are going to be using Ansible playbooks to configure a network switch. So, good luck.
That's very, very good news indeed.
Excellent. Okay. So OSM, we've created two terms to describe how we're going to be performing these operations. One is by proxy, where the charm, the operations code that runs to configure the network service is going to run at arm's length from it. So it needs to have its own place to execute, and it's going to talk with the network function over the network. So in the case of, say, physical network functions, where we don't have the ability to change the software and we can't inject software into it at runtime, we still need to be able to run our code and make changes to it over its exposed API. So we're going to be operating on this by proxy. OSM is going to reach out to that network function and configure it over a network connection. The second type of charm that we use is what's called a native charm, and that is where the operations code itself will be written and executed inside the network function. So that is the type of software that's applicable for when the software is sort of more under your control. There's kind of two theories on how to operate network services. One is you should have a hardened, lockdown cloud image that contains all of the software and everything that is needed, and nothing gets installed at runtime. The extreme opposite of this is the dynamic network service, where you're going to start with what we call just enough operating system. So that's only the bare minimum, something like an Alpine container or a unikernel or something like that, where there is or a base Ubuntu or Red Hat cloud image where there's only the operating system on it. And then at deployment time, you download, install, and configure all the software at runtime. And that's where native charms can be useful. Is the proxy another machine, or does OSM act as a proxy? Both. It really depends on how you install and configure your OSM environment. OSM can have its own execution environment within its configuration and installation, or you can register external execution environments that maybe coexist with your software. So say you're in the case of a multi-data center situation where you've got 10 data centers scattered throughout the continent. You can actually have an execution environment that is co-located in each data center, and OSM can have the operations run in a distributed fashion that way. So the proxies would be local to the data center, kind of remote from OSM, but OSM would still be able to talk to them that way. So it's not running inside the OSM containers. There always must be either a Kubernetes cloud or a LXD cloud or something like that where we would bring these operators up in. But those operators can be located, these clouds can be located in different places as the network grows and depending upon the security groups and how you want to configure your network. So, the scenario for this Hackfest this week. We're going to pretend that you're a telco operator and you're going to want to offer network as a service for small businesses. So the idea here is that you're wanting to provide an over-the-top set of services that is targeted towards small businesses, so that they can rapidly be able to spin up an environment where their employees can work. So you already have a cloud computing environment that's set up. It's got a Kubernetes cluster. It's got an OpenStack virtual infrastructure manager, or VIM, NFVI, Network Function Virtualization Infrastructure. These are Etsy terms that I'm throwing around, and I promised the last Hackfest we would have a glossary, and I didn't create one. My apologies. I'm going to work on doing that this time around. And so you're going to need to deploy several services to have your offering ready for the small business to just come in and start using. So we're going to have a firewall to make sure that people don't get unauthorized access. We're going to have an LDAP server, which is a user authentication system where you can add and remove user credentials so that only certain users get access. We're going to have a wiki server for your internal documentation. We're going to have a virtual PC for each employee. You see, the whole idea here is that these small businesses don't have a lot of capital, and they don't necessarily need to spend the cost to lease laptops and then manage them and deal with the whole bring your own device type of infrastructure. So this, in typical remote fashion, says, well, you can use whatever device you want, but the desktop that you're going to be working on is going to be located inside our cloud. That way, we have full control over the environment. We can update software, we can remove software, we can do whatever is needed, perform whatever maintenance we want on it. And as a cloud-based desktop, we can give you 100% 99.999 level of 5 nines level of uptime on it, because we can perform maintenance on the infrastructure underneath and just move this virtual desktop around as needed. And we're including centralized service monitoring to keep tabs on things, make sure that things are performing well. And we decided kind of at the last minute, we're adding one more service. We initially had it, we took it out, we brought it back. It's called a web cache or a web proxy. So rather than each and every employee's request going out to the internet and downloading YouTube videos, we're going to have a centralized web proxy that they can use. And if needed, you can block certain sites so that they have to use their own home computer to go surf the internet instead of going through your corporate resources. So what does this look like? So over here, we've got the employee, which, by the way, you're going to act as your own employee for this week. So you're both the system administrator and you're going to be coming in and seeing these things as if you were the employee as well. Here is the firewall. Behind the firewall is a private network that the virtual desktop sits on. They'll be able to reach the internal web server, the internal wiki from that. It will be able to communicate with the internal LDAP for authentication. We have the Squid web cache over here, where it's going to go here to look for content first, and then if it's not found, that will go around and out back to the internet to download content on their behalf. And we're going to have a performance monitor system, keeping an eye on things, giving us an idea of how well we're performing. Seems simple enough? So, what is this firewall? We have used this in previous Hackfests and found it to be a really useful little example. This time, though, we're going to be going in a little bit deeper into the firewall, and as mentioned, we're going to be able to see Ansible in use here. So this is a network device. It's actually, software that forwards packets between networks. That's all it really does. But it can, inspect packets. It can do network translation on packets, so that, let me just go back here as an example. We could have 10 of these virtual desktops all going, in and out of the internet. But there's only one point of presence on the internet here. So when these virtual desktops get content from the internet, they are going to need to have network address translation performed on them, so that there's only one IP address exposed on the internet. And this firewall takes care of the state saying, oh, this was virtual desktop number 1 that made this request, and desktop 2 made this other request. So when when desktop 1 goes to YouTube and desktop 2 goes to Google, it knows who to send the data back to. So it's got to maintain all of this stateful information inside of this firewall, so that it can deal with making sure that the right people get the right traffic. This software was pre-installed by your IT department. Because this is a security piece of software, and your security team happens to be extremely diligent. I won't say paranoid, diligent. They didn't want this software to be changeable on the fly. They said, as far as this firewall goes, this is going to be out of your control. All you can do is manage it. So you can't upgrade it. You can't install it. It's not going to show up on demand. This is something that was pre-installed. So this will be treated as a physical network function, because we're not doing any lifecycle operations on it. So what is your virtual desktop? This is just simply a vanilla cloud image, directly downloadable online from cloudimages.ubuntu.com. And that cloud image, when you download it, it's 250 meg or something like that. It is what we call just enough operating system. All you can really do is SSH and log into it, and it's got some network stack capabilities, but it doesn't have much useful software. So once this is brought into your system, we then, as part of OSM, are going to be adding the complete Ubuntu Focal Fossa desktop, complete with remote desktop protocol software, web browser, code editor, etc. We're going to add all of this software using OSM. And there we provide day 2 software management, which is you can add software to it, you can upgrade the software packages on it, and you can remove software. So we're going to be able to perform some management of this desktop through OSM. So you don't even need to log into it. And if there's 10 of them out there, you can just simply, execute the same command on all 10 without having to, remember, okay, this one's at IP.12, this one's at IP57. You don't need to worry about that. OSM is capable of taking care of all of that for you. LDAP. What is LDAP? Oh, sorry. One last thing. This is a VNF. It's a VNF that is backed by a virtual machine running on OpenStack. So, LDAP. This is the Lightweight Directory Access Protocol, which is a hierarchical database for user management. And it is going to, you're going to be able to add and remove users from it and change passwords. It's a relatively simple thing. LDAP uses its own set of commands and its own set of tools for infrastructure management. These are container images that come right from upstream OpenLDAP, and they're going to be deployed using Helm charts. So OpenLDAP has published already its own set of Helm charts, just like the firewall has its own set of Ansible playbooks published. So we're just going to show how OSM can leverage Helm charts and be able to deploy software that way. So this is a Helm managed, what we call KNF. It's still a virtual network function. At the SOL specification level, there isn't really a concept of differentiating between containers and VMs. They're all just network functions that have been virtualized, but we call them KNFs to help make sure that we understand that distinction during the Hackfest and during OSM lifecycle. So what is the wiki? This is an Apache HTTP server with a load balancer in front of it. And the idea here is that as the user hits the wiki server and you get more and more users using these back-end HTTP, Apache HTTP servers, it is going to scale dynamically. So after a certain period of time, a certain threshold, CPU usage, network usage, whatever it is that whatever stress we put on it, OSM is continually monitoring through OpenStack. It's monitoring the statistics of these. And once a certain threshold has been passed, it's going to start up a second instance automatically, or a third instance, or a fourth, or a fifth. And when the traffic stops and there's no longer demand for them, it's going to start scaling back in or terminating the unused instances and basically freeing up those resources in your infrastructure to do other things. So this is a regular VNF with scaling. Performance Monitor is a Kubernetes network function with relations. So this is using Prometheus with a Grafana, for those that may have not have heard of Grafana before, a web interface that allows for the plotting and visualization of data. So there's a centralized Prometheus server that will have what are called node exporters living out in your network that are going to provide data for Prometheus to gather and store, and then you're going to be able to report on that with Grafana. The Squid server is the first thing that we're going to be putting the node exporter on and taking a look at and finding out, okay, what do our web statistics look like? This is accomplished through what we call relations. Now, you may remember when I was talking earlier about the database being created and usernames and passwords being generated. Relations are an important concept in orchestration because they allow you to exchange data between two network units, virtualized functions, without operator intervention, without human intervention. So if I have, say, a database and a web server that happens to contain something like WordPress behind it, that WordPress is going to need to have credentials to the database. I can form a relationship between WordPress and the database that says exchange credentials information, basically. So the relationship on WordPress says, I need a database. I require a database username and password. And on the database side, it's going to say, I provide usernames and passwords. And when these two systems come up, they're going to be made aware of each other, and they're going to exchange this information so that WordPress is capable of knowing how to log into the database, and that password was never stored anywhere, and it wasn't transmitted anywhere in the clear. So here is one of the things that OSM can do. You've heard me talk about, PNFs, you've heard me talk about VNFs and KNFs and hybrids and proxies and natives and all this sort of stuff. The reality is not everything is going to be a brand new, shiny, clean, oh, I got to design this right from the ground up type of environment. Not everything is a Hackfest where we can control what it looks like and we decide ahead of time what we're going to do. The reality is that we're going to need to be going into data centers. We're going to need to be designing for environments where there are some PNFs. There's strange network configurations. There's odd routes in between here and there. There's going to be virtual functions. There's going to be OpenStack. There may be Azure. There may be Fog5. There may be Amazon Web Services. There may be all of these different places where things happen. There's different Kubernetes clouds. They're located in different places. And OSM is designed to be able to manage all of these. So this here is where we talk about the creation of execution environments. This says LXD operators, but it could be Kubernetes as well. So just because I'm putting LXD up here doesn't mean that it has to be LXD. It could be Kubernetes as well. So OSM creates these operator execution environment spaces where our operation code can run. In this case, these are all proxy charms. And OSM's going to inject the code into there, and they will be able to reach out to our physical network functions and virtual network functions and control them. So the question was, does the proxy charm need to exist, or does it live with OSM all the time? No, it could be co-located near to the resources, or it could be co-located with OSM. Multiples of these can be in play, and depending upon your architecture and how you've designed it, it can go into different places. Next is the native charm VNF, where we're going to be able to execute that code right inside the VNF, and that code maintains the same life cycle as the VNF. When I talked about the virtual desktop, this is what it looks like. So I don't need to, SSH into this VM to perform actions. If I want to install new software, I don't have to have, some proxy code sitting out here saying, okay, I'm going to SSH into that VM, into that desktop, which means that I would need to know the credentials. I need to have a dedicated user and password, or make sure that nobody interferes with the SSH keys. Instead, we use the code, the operator code, living right inside the VNF, and it right in place can talk to the apt repository inside the VM and not even shell out to the command line at all, but manage the system natively. Then the same pattern happens for K8s. So we can have proxy charm code that lives with a KNF. So it would look a little bit like what we call the sidecar pattern. You would bring up an additional container in the same pod, and it would be able to manage the KNF natively, or sorry, inside the pod. Or you could have a native charm inside the KNF, which is actually part of the container image. So the code would run alongside the software that it's managing. So charms are really just a set of packages that can drive applications. We've got things like backup and restore. In the case of the desktop, add repository, add package, perform an upgrade on it. These are all what we call operation primitives. And all of these things can be managed through open source MANO. So there's nothing, sort of magical or hidden going on with what charms are. They're just simply scripts. And to mention, one of these actions here could be, run an Ansible playbook. So Ansible is brought in and will be managed the same way as other charms are done. And we're using the exact same mechanism that is inside of the descriptor of the network service and inside of the description of the network function. We say, here is an action, which under the hood corresponds to an Ansible playbook, and here are the values or parameters that we're going to pass through to that playbook. And then the charm code takes over. It looks, okay, I have the data I need. What do I need to do? I'm going to now call Ansible and pass these variables through to Ansible. So there's not a lot of code that happens in the charm at that point, but it's an example of how additional orchestration or automation tools can be brought in, and you don't need to lose your investment in them. We have like the charm code base upstream has Puppet and Chef and other ones available as well. So we're not restricted to writing our own charms. We're not restricted to just using Ansible. If there happens to be Puppet or Chef, there are integrations available for that as well. And really, a charm is code. It's scripts that drive your applications. It can be just about whatever you need it to be. So going to our big picture, here we have our firewall with our physical network function orchestration. We've got our virtual network function orchestration. The creation of the wiki server is going to demonstrate some network automation where networks are created on demand. We're simplifying the network automation in that we're not using SDN overlays or underlays in any of this here, right? This Hackfest. So the network automation is touched on, but we're not diving deep into all the capabilities of network automation. We have monitoring and horizontal scaling going on. We also have external monitoring where the performance monitor is watching certain things that are going on in the network. We have a relation between Squid and the performance monitor that's created on demand so that you can see how relations work. And we have Kubernetes network function orchestration via Helm. So this is the big picture. This is the week ahead. Hopefully, this is a bit simpler. We don't have to worry about a lot of telco information, a lot of, the back-end network protocols so that we can concentrate more on what it is that OSM can do and spend a bit more time playing with things, which is the important part of a Hackfest. We want to hack at things. Okay. I should probably do a time check. How are we doing for time? Did I end on time today? Oh, sorry, I see one quick question. All of the packages and sources this week, are they open source? Absolutely. So we should be able to, anybody should be able to recreate this from open source packages.